Section 2. Interest rate swaps. In a plain vanilla interest rate swap, one party periodically pays a cash flow determined by a fixed interest rate. This is known as the fixed leg, and receives a cash flow determined by a floating interest rate, known as the floating leg. The other party does the opposite. The fixed rate that makes a swap's initial value zero is called the swap rate. The floating rate payment is linked to some short-term interest rates quoted at the start of each swap period. These short-term rates vary from period to period and are thus referred to as floating rates. One commonly used floating rate is the London Interbank Offer Rate, LIBOR for short, which is the rate of interest offered by banks on deposits from other banks. It is a reference rate of interest for loans in international financial markets. The fixed rate for a plain vanilla swap is usually quoted as some spread over benchmark US Treasuries. A quote of 30 over for a 5-year swap says that the fixed rate will be set at the 5-year Treasury yield plus 30 basis points. Now let's go further into the details of how an interest rate swap works. Suppose party A agrees to make payments of a fixed rate R on the notional principal N to party B, while receiving from B floating rate payments on the same notional principal, for a total of N periods. Let Ci denote the floating rate at time point I, for I from 0 to N-1. Then the cash flow received by A can be expressed as follows. Note that the net cash flow Ci minus R times N is established at the beginning of each period I, but it is usually paid out at the end of that period. That is, the payment is settled at the time point I plus 1. This is called paid in arrears. In the case when the payment is settled at the beginning of each period, we call it paid in advance. Here's an example. Consider a 3-year interest rate swap initiated on March 5, 2013, between companies A and B. Suppose that the company A agrees to pay to B an interest rate of 5% per annum on the notional principal of $100 million. And in return, B agrees to pay A payments based on a 6-month floating rate on the same notional principal. The agreement specifies that the payments are to be exchanged every 6 months. Both the swap rate and the 6-month floating rate are quoted with semi-annual compounding. Can you determine the detailed cash flow streams for this swap? This table shows you the cash flows to company A throughout the 3 years. The dates indicated in the first column are the beginning dates of the periods. The floating rates are determined on these dates and are listed in the second column correspondingly. For example, on March 5th, 2013, the 6-month floating rate is quoted at 4.2%. Then, the floating rate applied to the period from March to September in 2013 is 4.2%. Note that the interest rate is quoted annually, but with semi-annual compounding. Since the notional principal is $100 million, Company A would thus receive $2.1 million at the end of the period, that is, on September 5th, 2013. With the given floating rates for all periods, we can calculate the rest floating cash flows received by Company A. Since the fixed rate paid by Company A is 5% per annum with semi-annual compounding as well, it is easy to get that the fixed payment amount for each period is $2.5 million. Thus, we can get the net cash flow stream to Company A for the 3 years, which is listed in the last column. Here, the $100 million principal is used for the calculation of interest payments only. The principal itself is not exchanged. That is why we call it notional principal. Actually, the exchange of the principal at the end of life of the swap have no financial value to either A or B. If the principal were swapped at the end, the cash flow table for the previous example would look like the following. The only difference is the cash in and outflows for the last period. However, the net cash flow remains the same. Although the actual swap doesn't involve exchanging of the principal, taking into account of which helps us to evaluate the swap. In the previous table, the cash flow in the third column is essentially the cash flow from a long position in a floating rate bond, whereas the cash flow in the fourth column is equivalent to the cash flow from a short position in a fixed rate bond. In general, the floating rate cash flow stream is exactly the same as that generated by a floating rate bond, with principal N and maturity M, except that no final principal payment is made. Therefore, if we know how to determine the floating rate bond, we will be able to evaluate the swap. Like the fixed rate bond, a floating rate note or bond has a fixed face value and a fixed maturity, but each coupon payment is tied to the rate of interest at the beginning of the corresponding coupon period. For example, consider our fixed rate note paying coupon payments every 6 months, with the reference rate being a 6-month floating rate. When the bond is issued, the coupon rate for the first 6 months is set equal to the current 6-month floating rate. At the end of the 6 months, a coupon at that rate is paid. After the payment, the rate is reset to the then 6-month floating rate. The process continues until maturity. Since the coupon rate is reset to reflect the prevailing market rate, the value of a floating rate bond is equal to par at any reset point. Let's show the result by working backwards. At the time point M, the bondholder will receive the principal N together with the last coupon payment, whose rate Cm-1 is determined at the time point M-1. Thus, using Cm-1 as the discount rate, the value of this bond at the time point M-1 after the M-1's coupon payment is exactly the principal N. Now, if we're at the reset point M-2, that is, after the M-2's coupon payment, we know that the bond would have value Cm-2 times N plus N at the time point M-1. Therefore, the value of the bond at the time point M-2 after the M-2's coupon payment is also equal to N. Working backwards period by period, we can get that the bond value is always equal to par right after the coupon is paid. Now we are ready to value the interest rate swaps. Since the initial value of the floating rate bond is par, the value of the floating rate portion of the swap stream is par minus the present value of the principal received at maturity. The calculation of the value of the fixed rate portion is straightforward. Simply sum up the present value of all the fixed rate payments. Now that we have both the present values of the floating payments and the fixed payments, the initial value of the swap to the company receiving floating and paying fixed can be calculated as follows. Rearranging the formula, we can get the following expression, which is exactly the difference of the floating rate bond value and the fixed rate bond value. By taking out the common factor N, we get the following equivalent expression. Similar as the commodity swap, the value of the interest rate swap is also set to be 0 when it is initiated, and the chosen fixed rate R, such that the initial value of the swap is 0, is called the swap rate. After the swap has been in existence for some time, its value may become positive or negative. To determine the value sometime after the initiation of the swap, we regard the swap as a long position in one bond combined with a short position in another bond. We're going to study the details in the next lesson.